Hello and welcome back. This video covers the quiz review on adding, subtracting, multiplying, and dividing rational expressions. So number one, we're multiplying these two fractions together. We can factor just about everywhere. The x squared minus 2x, we can factor out an x there. This denominator also factors into x plus 1 times x plus 1. This numerator will factor into x plus 1 times x plus 3. And in this denominator, we can factor out an x. So that would be x times x plus 3. So that's what this looks like. All right, and then we can start canceling out because it's multiplication. So these two x plus 3's will cancel each other. The x plus 1 and this x plus 1 will cancel each other. This x will cancel with that x. And then we'll have x minus 2 divided by x plus 1 left over. And that is our final answer. All right, here's number 2. We can factor the 4x squared minus 16 by pulling out a 4. The 5x minus 10 we can factor by pulling out a 5. We can pull out a 2 from the 2x plus 4. All right, and doing that results in this expression. We have the 4 times x squared minus 4, 5 times x minus 2, and then 2 times x plus 2. We can then factor the x squared minus 4 into x plus 2 times x minus 2. And that brings us to step B. Now we can start canceling out. This x plus 2 will cancel with this x plus 2. This x minus 2 will cancel with that x minus 2. We will have a 4 times a 1 left on the top. That'll be 4. And we also have 5 times the 2 left, and that's 10. So we have 4/10, and then that reduces to our final answer of 2/5. All right, here's number 3. This is a division problem. So first, let's go ahead and factor everywhere that's possible. And then, because it's division, we'll end up changing that to multiplication and then flipping the second fraction. But again, I'm going to factor everything first. So the 5x squared minus 20, I'm going to factor out a 5 from that. I can factor the x squared plus 6x plus 8 will factor into x plus 4 times x plus 2. And the x squared plus 10x plus 24 will factor into x plus 6 times x plus 4. So that results in what we have here in step A. Now we're going to flip this fraction. Oh, but we can also factor the x squared minus 4 next. So x squared minus 4 will factor into x plus 2 times x minus 2. That brings us to what we have here in step B. Now the division, we go ahead and change that to multiplication, and then we end up flipping this second fraction. So we have the x plus 6 times the x plus 4 on the top with x plus 4 times x plus 2 on the bottom. Now we can start canceling out. This x plus 2 will cancel with this x plus 2. This x plus 4 cancels with this x plus 4. And let's see, and then I believe that would leave us with x minus 2 on the top, along with x plus 6 on the top. We'll still have the x that's next to the 10, that's still on the bottom. But we can reduce the 5 over 10 to be 1/2, or 1 over 2. So this will be our final answer. Okay, and with number 4, we see that we've got these two fractions, and we're dividing. So let's just go ahead and change the division to multiplication and flip the second fraction. And that brings us to part A here. So we change to multiplication, and the second fraction has now flipped. Okay. In step B, I just multiplied straight across the 12 times 2 gives me the 24. The x squared times x is x to the third, because you just add the exponents there, and y times y is y squared. On the bottom, you'll multiply 5 times 6 to get 30. Then you bring down your x squared and your y to the fourth. In step C, we just finish everything up. We can reduce the 24 over 30. That becomes 4/5, because I can divide both of those numbers by 6. I can subtract the exponents. The 3 minus 2 leaves me with x to the first on the top. And then if I subtract the y's, that'll be 2 minus 4. That would give me a negative 2. And so that means I would end up moving it to the bottom. So to have y squared on the bottom. All right, so you have your final answer is this 4x divided by 5y squared. All right, in number 5, we are subtracting these two fractions. So that means we have to get a common denominator. So in step A, we recognize that our common denominator is going to be x plus 5 times x plus 1. So in the first fraction, the x plus 1 is missing, so we'll multiply by x plus 1 on the top and bottom. In the second fraction, x plus 5 is missing, so we'll multiply the top and bottom by x plus 5. In step B, we actually do the multiplication. So here you're distributing 3 times x plus 1, and that gives you 3x plus 3. Distribute the 4 times the x plus 5, and that's going to give you 4x plus 20. And then we just say it's all over the LCD, which of course is x plus 1 times x plus 5. All right, then in step C, we combine the numerators. So we're just adding the like terms together. 3x minus 4x is negative 1x. And then 3 minus 20 is negative 17. Now you could just leave your answer like this, or you could factor out a negative 1 from the numerator, and that would leave you with the negative of x plus 17 all over x plus 1 times x plus 5. All right, in number 6, we're adding these two fractions together. And then we always want to factor wherever possible, so in the 2x plus 8, we can factor out a 2, and that'll be 2 times x plus 4. Then the 2 and the 4. The 2 and the 4 can reduce, so 2 goes into 4 twice. So that just leaves you with the 2 on the top, and the 2 on the bottom is gone. All right, and then that gives us a common denominator already, so now we can just add the two numerators together, and that's going to give us 5 over x plus 4. Final answer. Okay, in number 7, we're adding these two fractions together, so we need to get a common denominator. The common denominator is going to be 18x, because 6 can go into 18. So we'll need to multiply this first fraction by 3 on the top and bottom. So in part A, we're multiplying this fraction by 3 on the top and bottom. And of course, that brings us to part B, where we have 3 times 5 is 15 over 3 times 6, that's 18x. And now that we have a common denominator, we'll just combine 15 plus 7. So we have 22 over 18x. And then in step D, we're just reducing to lowest terms. So we can divide both numbers by 2 and get 11 over 9x for our final answer. Okay, in number 8, we have 3 fractions that we are subtracting and adding together. So we'll need to factor everywhere and make sure we have common denominators. So here we have step A, where we factor the x squared plus 4x plus 4 into x plus 2 times x plus 2. X squared minus 4 in the second fraction factors into x plus 2 times x minus 2. And then we just bring everything else down. So our common denominator is going to be x plus 2 times x plus 2 times x minus 2. So we multiply each fraction by whatever is missing in the denominator. So now in step B, we see that the first fraction was missing the x minus 2. So we multiply by x minus 2 on the top and bottom. Second fraction is missing an x plus 2. So we multiply by that on the top and bottom. And the third fraction is missing both of the x plus 2's. So we're multiplying by x plus 2 times x plus 2 on the top and bottom. Now to make it just a little bit easier or simpler, we go ahead and multiply the x plus 2 times x plus 2 together to get x squared plus 4x plus 4. And then we're multiplying all of that times the 3 that's in front. That brings us to step C. After distributing the x minus 2 times 2x plus 1, we get this expression here, 2x squared plus x minus 4x minus 2. Distributing the 6x times x plus 2, we get 6x squared plus 12x. And when we distribute the 3 times this polynomial, we get 3x squared plus 12x plus 12. And all of that is over our least common denominator. Now we can go ahead and combine the like terms. And that brings us to step D. So if we combine 2x squared and negative 6x squared, and then plus 3x squared, that's going to give us negative 1x squared. If we combine x with minus 4x, and then minus 12x, and then plus 12x, we just end up with negative 3x. And finally, if we combine the negative 2 with the positive 12, we get positive 10. Now we're still not done. That brings us to step E, where if we factor out a negative 1 from this numerator, we'd have negative 1 times positive x squared plus 3x minus 10. And this can be factored, which brings us to step F. This polynomial can be factored into x plus 5 times x minus 2. Now we can cancel out the x minus 2's. And so that brings us to step G, where it's just going to be the negative of x plus 5 over x plus 2 times x plus 2 for the final answer. All right, number 9, we're subtracting these two fractions together. So in step A, we factored the denominator here to x minus 2 times x plus 1. And now we're going to find our common denominator and then multiply by whatever's missing. So in the second fraction, the x plus 1 is missing, because our common denominator is x minus 2 times x plus 1. So the x plus 1 is missing from this second fraction. So we multiplied the top and bottom by x plus 1. Now in step C, we just multiply the x plus 1 times 1, and that's just x plus 1. That brings us to step D, where we just combine like terms in the numerator. So 2x minus x is just x, and negative 1 minus 1 is negative 2. Now you'll notice that the x minus 2 on the top will cancel with the x minus 2 on the bottom. And that brings us to our last step, E, and that final answer is just 1 over x plus 1. All right, in number 10, we have 3 fractions, and it looks like we're dividing by the second fraction, but then multiplying by the third fraction. So again, I'm going to use the strategy of factoring first, and then we can flip and cancel out. So let's factor. This numerator here will factor into x minus 2 times x minus 1. The 2x plus 4, we can factor out a 2, and that would give us 2 times x plus 2. And in this denominator here, we can factor out the 5x. So that would give us 5x times x minus 1. Now in the next step, this division will change to multiplication, and then we'll end up flipping this fraction. And that gives us the 3x over x minus 2. Now we can start canceling some things out. A lot cancels out, as a matter of fact. This x minus 2 cancels with this x minus 2. This x minus 1 cancels with this x minus 1. This x plus 2 on the bottom cancels with the x plus 2 that's on the top. And all of the binomials cancel each other out. The only thing left now are the coefficients. We have a 3 and a 2, and that's 6. Oh yes, this x right here, this x on the top cancels with this x on the bottom, so those x's are gone as well. So again, on the top you have the 3 times the 2, which is 6, and then you also have the 5 that's in the denominator. So your final answer is just 6 over 5. All right, here is number 11. We have what we call a complex fraction, and that's a fraction where we have fractions within the larger fraction. What we want to do is we want to try to get rid of the smaller fractions. So we'll need to factor wherever possible, and then we're going to multiply the top and bottom by the least common denominator. So first we notice that we can factor x squared minus 9. And then in step A, that's going to factor into x plus 3 times x minus 3. And then everything else we just bring over. Now our least common denominator is going to be x plus 3 times x minus 3. So in step B, we're going to be multiplying the top and bottom by x plus 3 times x minus 3. Now, x plus 3 times x minus 3 multiplied by this fraction will cause the x plus 3's and the x minus 3's to cancel with those on the bottom. That's just going to leave us with 4. So let's see what we have in step C. Yeah, so that'll just leave us with the 4 here because the x plus 3's and the x minus 3's cancel each other out here. Okay, now when we multiply x plus 3 times x minus 3 multiplied by this fraction, only the x minus 3 will cancel with the other x minus 3. That will leave you with the 2 here and the x plus 3. So that's 2 times x plus 3 over here. Let's go to the denominator. So when we multiply x plus 3, x minus 3 times this fraction, the x plus 3 will cancel with this x plus 3, leaving you with x minus 3. And that's what you see here. Then finally, we'll multiply what we have on the outside times this fraction. And the x minus 3 here will cancel with this x minus 3, leaving you with x plus 3. And that's what you see here. All right, brings us to the next step. Step D. If we distribute the 2 into this parentheses, we get 2x plus 6, and then we just add the 4 in front. Now, you're adding these two expressions. So this x plus that x is 2x. And then minus 3 and positive 3 cancel each other out. In step E, you're adding the 4 plus the 6 together to get 10. And then for our final answer, you just simplify by dividing all the coefficients by 2. So you'll get x plus 5 over x for your final answer. All right, here's our last problem, number 12. Again, we have a complex fraction because we have fractions within a fraction. So the strategy would be to find the common denominator and multiply the top and bottom by the common denominator. Well, the common denominator between x and x squared is just x squared. So in step A, we're just going to multiply the top and bottom by x squared. We'll need to distribute, so we're multiplying x squared times 1 and also x squared times 3 over x. On the bottom, you're going to be multiplying the x squared times 2 and x squared times this fraction, 5 over x squared. So the result is what you see in step B. So that's x squared times 1 is x squared. X squared times this fraction is 3x squared over x. Well, then the x will cancel with one of the x's, so that would just leave us with 3x. On the bottom, you're multiplying x squared times 2, which is 2x squared, and then x squared times this fraction would cause the x squareds to cancel each other, leaving you with just the minus 5. And now we're pretty much done, except we can factor out an x that's in the numerator. So our final answer is going to be x times x plus 3 all over 2x squared minus 5. All right, that's it, folks. I hope this information was helpful as you're preparing for the quiz on adding, subtracting, multiplying, and dividing rational expressions.